Hello, class. Today, what we are going to talk about is translations. Translating figures, you'll remember this from earlier classes. These are slides. We just move it over and stuff. But before we talk about translations, we are going to talk about vectors. All right? Everybody remembers vectors from Despicable Me. This is something that has both direction and magnitude. All right? Now, if we look at the graph, the picture of this vector, we see it starts at point P, it goes to point Q, it's got this nice little arrow. It looks a lot like a ray. It is, however, not a ray. There is a big difference, and that is that rays go on forever while vectors stop. Okay? A vector PQ just goes from point P to point Q and it stops. It has the arrow because the direction matters. We're going in this direction from here to there. So that's why we have the arrow there. And so, since it stops, it does have endpoints, but we're not going to call them endpoints because we want to specify this is the first one and this is the last one. So the first endpoint, where it starts, that is the initial point. Initial, because that's the starting point, just like the starting letter in your name is the initial letter. All right. The ending point, the stopping point, that is the terminal point. All right, just like the stopping point for a bus stops at the bus terminal, the airplane stops at the airplane terminal. All right, the vector stops at the terminal point. The way we will name the vector is just like we name array, the starting point to the ending point. Vector PQ. Now this copy did not come out very good. This should have a nice little arrow just on the top. It's like half of the arrow for array. Makes it look kind of like a fish hook. All right, so that should be like that. That would be vector PQ. All vectors have two components. They have a horizontal component and they have a vertical component. All right, the horizontal component says we are going to go 5 units to the right. So we have a positive 5 units to the right. And we are going to go 3 units up, so we have a positive 3 for 3 units up. And we will write this in component form, which looks like this. And just so you see, these are not parentheses. These are these nice little angled brackets. All right, I forget what the actual name is, but that's what they are. Little angled brackets. They look a lot like greater than, less than signs, only they're a lot wider. All right. So this is component form. This means move 5 units right and 3 units up. Okay. We are going to look at a couple of examples of these. So let's open this up. All right. So what we have, number 1, 2, and 3, we want to write the name of the vector, and then we want to write its component form. So looking at this first vector, we have, there's our arrow. So this is our initial point. That's our terminal point. We go from start to finish. So the start is M. The finish is N. So this is vector MN. Now, we want to do the component form. So we're going to open up these nice angled brackets there. And we'll take the horizontal first, just like in an ordered pair. So let's see, we would move over 4 units there to the right. So that's 4 units to the right for our horizontal component. And then we're going to go up 1, 2, 3, 4, 5, 6. So the vertical component is 6 because we go 6 units up. And so there is the component form. All right, not too bad. Let's take a look at number 2. Number 2, we have vector, and we go from starting point to ending point. Well, we see our starting point is over here. That's point B. The initial point, the terminal point is point A. So this is vector BA, like so. Now, the horizontal component of this, one's component form. So we're going to go from B to A. So this time we're moving to the left. We went 5 units to the left. Left is in the negative direction, so we're going to call this negative 5 to show that it's going to the left, not going to the right. Okay. The vertical component, well, we would go down 1. And so to show we're going down, we're going to do negative 1. All right. So if you move to the left, it's a negative. If you move to the right, it's positive. If you go up, it's positive. Down is negative. Let's take a look at number 3. In fact, I would like you to pause the video and write the name and the component form for number 3, and then come back. Okay, that didn't take you very long. Hopefully you said, well, K is my initial point, J is my terminal point, so this is vector Kj. And then for the component form, you said, well, from K to J, that is 5 units to the left, so that's -5. And then we're going to go up 3, so that's a +3. And that is the component form for vector Kj. All right. So that's not too bad. That's easy stuff. Why do we need that for transformations, for translations? Well, let's take a look at translations. A translation moves every point from one figure the same distance in the same direction. All right. And what we do is we say that this translation maps the points PQ and everything in between it. So segment PQ to a figure along the vector with components AB. All right. And what this does, this is going to map to the points P prime and Q prime. All right. That's with this little apostrophe up there. That is read as P prime. And it shows that P prime comes from point P. All right. So that's why we have P prime. Q prime is coming from point Q. All right. Now, when it does this, what it does, the segment P prime, Q prime, this is called the image. All right. The image. It is made in the image of the original. It is not the original. It just has the image of the original. The original is called the pre-image. Pre-image is the original one. Okay. Now, when it does this, when it moves from point P to point P prime, from point Q to point Q prime, it creates this segment, P prime, and this segment, Q prime. And these two segments that connect the points that are being mapped will always be congruent, and they will also be parallel. Congruent because they're moving the same direction. Congruent because they're moving the same distance, so they have the same length. Parallel because they're moving the same direction, so they have the same slope. All right. Now, so there's that. And the coordinates, if you'll notice here, you take the original coordinates, the original x value, and you add the horizontal component of the vector, and that will give you the new x value for your image. For the horizontal, you take the y value of the pre-image, you add the vertical component of the vector, and that will give you the y value of the image. All right. So we do real quickly, we have two postulates, well, a postulate and a theorem. So the translation postulate says a translation is a rigid motion. Okay. Now, what's a rigid motion? A rigid motion, what that is, that just means that you're going to move in such a way that it does not change size or shape. So if I take my pen and I move it down, I have translated it. The pen did not bend, the pen did not stretch, the pen did not grow wings, the pen did not do anything. It is still the same size, it is still the same shape. All right. So I'm going to write this definition right here. Rigid motion. What that means is it does not change size or shape. So it does not change size, or shape. All right. And so if the pre-image and the image are the same size and the same shape, that means that they are congruent. Okay, so a translation, it's a rigid motion, which means that the image is going to be congruent to the pre-image. All right. Next, the theorem down here, this is a composition theorem. What this says is that if you have a composition of two or more rigid motions, then it will still be a rigid motion. Now, a composition, what that is when you take two or more transformations and you put them together. So, for example, if I take this little pinlet and I move it up, then I move it over, then I move it down, this is three different translations. It is a composition. It puts them all three together. So if the first one is a translation, it doesn't change the shape. The second one doesn't change size or shape. And the third one doesn't change size or shape. Then doing all three of them together still does not change the size or shape. It doesn't matter how many times you don't change anything, you still haven't changed anything. All right? That's what this composition theorem says. Pretty, common sense, but they still need a theorem for it. All right, let's take a look at some of this stuff. Some of these, how we're going to use these. So in exercise 8 and 9, we want to write a rule for the translation of quadrilateral PQRS to quadrilateral P prime, Q prime, R prime, S prime. And yes, you do have to read it like that. It is not quadrilateral PQRS prime. It is P prime, Q prime, R prime, S prime. So what we're going to do with this, we are going to look at the vector that gets us from the original, which is the solid quadrilateral. We know that because it doesn't have any primes on it, to the dotted quadrilateral. So we're going to start from the one that has no primes to the one that does have primes. And I'm just going to pick a point, any point, it doesn't matter what it is, and I'm going to draw my vector from R to R prime. And let's see, the component form of this vector, I moved over 1, 2, 3, 4, and up 3. So my component form is 4, 3. All right. And just to check, we can do this up and pick another one. We can use S, why not? From S to S prime, and we see we also move over 1, 2, 3, 4, and up 1, 2, 3. So it's the same, no matter where we do it. We can do it over here, that's fine too. We move over 1, 2, 3, 4, we move up 1, 2, 3. All right. So this is the movement. The rule, what we want there is to say that, hey, we can do this for any X value, any Y value, any point on this. It's all going to work the same way. So our rule, we're going to say take any X, whatever X value you started at. Doesn't matter if it's R, doesn't matter if it's Q, doesn't matter if it's this point right here in between R and Q. Doesn't matter. Take the X value and you're going to add the horizontal value of the component of our vector, so plus 4. Then take the Y value. Doesn't matter what it is. The Y value for R, the Y value for this point right here, Y value for that point right there. And add the vertical component of the vector, like that. And this will give you the ordered pair of the image for that point. And since this is giving me an ordered pair, I'm going to put it in parentheses. I'm not going to use the little angled brackets. All right. And that's all it is. You just find the component form of your vector, and then it's just X plus the horizontal, Y plus the vertical. That's it. That's your rule. So I would like you to pause the video real quickly and find the rule that maps the image or the pre-image onto the image. All right. So pause the video and then come back. Okay, you're back. So let's take a look at this. Let's see. I'm going to draw my vector. I'm going to use point P. Why not? So P, let's see. I went down 3 and over 1. So my component form is -3 and +1. So the rule for this will be X minus 3, Y plus 1. And this is giving me an ordered pair, so I'm going to put it in parentheses so it looks like an ordered pair. And there it is. All right, so that's really pretty simple. Now, let's take a look at 10 and 11. What we're doing here is it's giving us the image, the pre-image, and it says, here's the rule. Just like we came up with the rule a minute ago, it's saying this is the rule that you're going to use. And the way we read this notation right here, this says the point XY maps to the point X plus 6, y minus 3. All right. So all we're going to do is we're going to take our point. This is our x, that's our y, and we're going to plug it in to this rule. So we have 4 plus 6 and 5 minus 3. Well, that's easy enough to do. 4 plus 6 is 10. 5 minus 3 is 2. So these are the coordinates of the image, J prime. Just like that. Pretty simple, right? Okay, what I want you to do, pause the video real quick, and I want you to work out number 11. What is the image of R prime? Just take the R, plug it into your equation. All right, hopefully you got this. Let's do this real quickly. So we are going to take the 0, plug that in for x. So we have 0 plus 6, and negative 5 is plugged in for y, so that's negative 5 minus 3. 0 plus 6 is 6. Negative 5 minus 3 is negative 8. And this is the image of R prime. So that means that this is R prime prime. The image of an image. And this is read as R prime prime, or it could also be called R double prime. But you know, it's just R prime prime. So, all right, we are going to do one more right over here. And what I want to do, it says 23 and 24, is whatever, 23. We want to describe the composition of these translations. So I've got two translations happening. Let's see, where's my original? The original is the one right here, ABC, no primes on it. And it moved from ABC to A prime, B prime, C prime, and then down to A prime, prime, B prime, prime, C prime, prime. You know, that gets to be a mouthful, don't it? So let's take a look at our vectors. I'm just going to use point A. Why not? So my horizontal component is 1, 2, 3, 4, 5. So 5. My vertical component is up 1. All right. And that's true for all of them. 1, 2, 3, 4, 5, up 1. Now to get from the image to the image of the image, I'm going to draw another vector going all the way down here. And so let's see, what did we do? A horizontal component, we're going backwards. So we're going negative 1, 2, 3, 4, 5. Negative 5. And we're going down 1, 2, 3, 4, 5. So down 5. And here is the cool thing about compositions. When it says to describe the composition, it's saying, well, this is the long way around. What would it be if I went straight down from here to there? That's what it wants to know. And the way these work with vectors, I'm just going to take these components and I'm going to add them up. That's it. 1 plus negative 5 is negative 4. 5 plus negative 5 is 0. This is my composition. And if you look at what I did in red, going from point C, I'm going horizontal. No, I'm not. No horizontal change at all. So that's 0. And my vertical, I'm going down 1, 2, 3, 4. So you can just take the components, add them up, and that will give you the composition. All right? So that's my answer. That's it. And this is translations with vectors. So not too bad, pretty simple stuff. I hope you found it useful, and I'll see you in the next video.